let's go into start. This is the formal section, the discussion. As I mentioned earlier in the day, we will be seeing Mentimeter. This is you can see in the screen. So you need to log into this web, menti.com, and then copy this code. The code is in the Slack channel in case you want to just copy and paste. It's as easy as doing that, but I include, yes, like the voting is closed. Wait, please. That's what. Oh, I had to do that. Oh, yeah, because I have to move on the presentation. Sorry. So, as we were saying, you have the code in Slack. In the meantime, you can copy from there. So from this, there will be 3 people in the panel. Rachel from the Software Sustainability Institute. She's also a member of the UK SRC. And she's a champion in open science. There is also Ruben, who is an astronomer from here at the institute, and there is also Susana, who is engineer. She's also a member of she's the coordinator of the Spanish prototype Skate Regional Center. So we have to cover different profiles, and that was our intention. So if you can come here. Okay, now it's working. As I move on. So just this is what you should be seeing in your laptop or by mobile phone. This is a test slide, so just you can write down your name or nickname as you prefer. If you want it to be more anonymous, that's okay. Okay, great. Just to have an idea of how things are working. Okay. Yeah, people keep joining, so let's just wait a little bit. Okay, just one comment about Menti. If at any time you are log out, you will see at the top side of the web browser a link telling you that you can jump to the current slide. Okay, that should be okay. So let's move on and start with the discussion. This is our first question for today. Did you share your data and code to produce the figures, at least the figures or maybe the results of your last paper? These are the options. Yes, I shared the data. I shared the code. No, I didn't. Just to say that you can select 2 options. So, for example, if you share the data and the software, you can mark both. Let's see what's happening. What? It's interesting. More or less, data and software are more or less equal. So maybe some of the people that didn't share want to comment. I mean, that's up to you. But I don't know if someone from the panel didn't share. Wait a second. Oh, that's okay. That's. Yeah, so everyone can hear you. Was not the board option, so I didn't do that because I didn't even think about that. Is it on the microphone? Can you repeat that? Yeah,
the answer I wanted to give was not among the options. So actually I didn't share that because I didn't even think about that. So that's big, because it was not a common practice. It's not a common practice. I haven't done that. Well, after this school, I would think about that at least. Then I may decide not to do it, but at least I would think about that.
Wait, which is I think that's a great answer. It's about thinking about that, and then you can decide. So, yeah.
Can I jump in? In my case, my answer is not there. I mean, I flagged the yellow, but in the last paper, okay, I couldn't properly share anything because of, I mean, it's commission and I mean, it's validation work, so it's something not purely, active research in astrophysics. There is no real, secret, obviously, but it's an activity that cannot be shared. So maybe in a future questionnaire, you can add this thing. I don't know, just to trigger the discussion. Sometimes you cannot completely share what you are doing because of agreements with I can be more detailed in my case, but sometimes it's not possible to immediately release something, no? Even in science. I know this is in conflict with the context of this school, but I just wanted to point out this.
So maybe Rachel or Ruben, do you want to answer to that?
Yeah, so this is Rachel speaking for anybody online. So yeah, that's a really good point, being unable to openly share the work that you do. So I know this school is targeted at astronomers, and so the data that we typically work with doesn't really need to undergo any ethics reviews, and there is no real kind of data protection or data rights for the stars and universe objects in the universe. So it's a lot less difficult for us to openly share our data, and it's more of a systemic issue that prevents us from sharing our data. But in a lot of domains, particularly when you're dealing with human information or animal rights and things like that, it's a lot more difficult to openly share, because that can have implications on, if you're sharing health data, if you don't fully anonymize your data set, that can have implications when it comes to getting insurance in countries particularly like the US and things like that. So being unable to share your data is a valid answer in a lot of situations, and it's something that the open research movement will need to contend with as it goes forward.
Okay, so I think that yeah, Lourdes.
I think that the results of the quiz is very positive. I wonder, do you think that this is a bias because the people who registered for the school is the people who are actually interested in that? Or it's because you couldn't convince anybody because this is after, so casually the time arrow says, so you think there is a bias in the people coming, or you think this is becoming the standard practice? Is this representative of reality, or is representing people who was interested in registering for the school?
I think a bit of them. It's a bit biased towards our interests here, but I think Rachel mentioned yesterday that there is a trend, and we see that there is a trend in trying to pushing this forward. So I think it reflects also a bit of the movement there and the intentions.
But even with this bias, I see the numbers very similar. So yes, I said my code answer is 11. No, I didn't know how to do it. It's 9. So even though it's so, well, I'm surprised that people even in this school is no, or I decided not to do it. So I would expect more in the red and yellow columns than that. So
Yeah, I think. Sorry.
Yeah, just for you to get the numbers correct, I also selected the last option because, because I didn't have any more option to choose. But that was not my. That was also not my my choice. But I just didn't share it because that was not part of the practice, like he said. So my option was also not among these four. So I didn't share it because I just didn't even think about it. So, but maybe also after the school, I will think about it. So.
Okay. Yes.
One more thing on here. Tom you submitted a paper on its own archive. Openly shared it on archive. And I think that's something to be, aware of. It's quite realized to automatically deposit what we do in a resource such as archive. That's started kind of research movements. I realize as astronomers, we are likely to only share our papers with the archive. We are likely to only share data via an excellent resource in NASA ADS where we can access all the literature and objects. And so we want to realize that that's something that I take for granted, especially early in my career. So
Can you give the microphone to Emilio?
I think that concerning data, the author is time to time more interested in making public the data in VCR or any kind of, of a public browser. So the use of the public data is now increasing very much in astronomy. And so it is an important source of station for the author.
As we were in, so something I want to also to comment, but until he gets the microphone. So we have to remind us that astronomy, we are pioneers in sharing data. So that's good. But as I was saying, I think it was, I don't remember today or yesterday, there are many institutes that have a mandate for sharing the data. So there is a mandate. So it's not really a choice. We have the mandate to share the data that is coming from our research. That's. I know that I already said that, but this is always important to remember. So please, José Francisco.
Yeah, just to comment about the publishing the papers in archive. Is this working? Working. Okay.
Close it. Yeah.
Okay. Yes. About putting our papers in the archive is, well, it's not necessarily the motivations are not necessarily openness. So because there was a common understanding that the papers that were uploaded to archive were more cited than those that were not. So sometimes the motivations are more selfish.
what if I told you I could get cited for publishing your data sets?
Okay. Okay, we'll come back to that probably later. So, this is connected to what you were saying before. So, did you ever find any difficulty or barriers to publishing the data or code? And in that case, what kind? Because I mean, now you can type if you want. You can type and get some answers. But in the meantime, probably I don't know, Ruben. Maybe you can comment on this. Does this happen to you?
Data, yes, but that's another issue is the format. If it's not a standard, for example, sonification are not all allowed in all reviews or journal papers. So that's and they don't think that's something worth to add. So that's more a kind of a format or other type of data. Close? Oh. No.
Okay.
Okay. And in that regards, that's an stopper, but that's a different, I think, different question from what you're asking here, right?
Well,
No, it's a barrier.
it's a barrier. I mean, you are kind of out of the regular data. So that's one important barrier. I mean, like the solutions that are there are not working for you because you cannot publish in BCL.
Indeed.
For example, that's a very important barrier, I would say.
But you can publish in Granada.
Yes,
You
but
can't put in Zenodo. I just want.
indeed, but it would be nice, I mean, to have everything in, I mean, if you can add appendix, like tables, whatever, why cannot I add this kind of other information?
Metadata.
Yeah.
Okay, so I don't know if Susana or Rachel, do you want to comment?
Thinking about it's true. If you don't have the right tool, maybe you have tools like Zenodo, but if you don't have a specific tool for your data, it's a problem because you feel that it doesn't matter if you put your data in Zenodo if there is no way for someone to access your data because the metadata. This happens to us when we upload the data in U2 data in this European service in the bank. So the metadata there was so general that if you don't have the link, you don't have the means to access to find this data. So I think it's yeah.
So we are having some answers in the slide. We can see if they're still moving. We can see that, for example, some people is commenting that it's difficult to host data, and that's true. And maybe not everyone should be doing that. I mean, like for example, there are institutions that have these platforms. They are already there. There is the virtual observatory in different regions and countries. So if you contact them, they can help you to publish data. This is an option. I mean, it's not the only one, but it's an option. There is also, for example, the case of medical data. I mean, that is sensitive. I mean, that's true. Probably not the case in astronomy, as Rachel was saying, but I mean, this is a very important fact in Europe. You have to anonymize the data before publishing it. That's very important. So, Stephen?
Yeah, so with regard to this and with regard to the previous question, I was just thinking about how in astronomy, how we are very, very fortunate to have things like Archive that we've just grown up with, and NASA ADS and SIMBAD, all of these open science tools do not exist in other disciplines, and it's a lot of the motivation behind EOSC that this findable, accessible, interoperable, reusable is not part of this common machinery. And so people like the people who work at the Virtual Observatory have had to map this fair methodology onto the stuff that the architecture that they've already created. And you don't have to go very far to find communities that just don't engage with this, even with the archive. So planetary scientists really do not engage, they do not put papers on the archive with anything like the frequency that astronomers do. And to me, they're just having a coffee. I mean, why not? This is mad. But there is a community there are communities where sharing of data is difficult, and it for good reasons. So, for example, there could be export restrictions for technologies, or there could be ethical reasons for restricting access to data sets. And so people say that data available on request to the authors. And this has percolated into astronomy. And so you see acknowledgement sections in data availability saying data available on request to the authors, or even on reasonable request to the authors. And you know what that means. It means no and bugger off. It's to share this. So I think if as a community, we should try to ban the words on reasonable request. That would be my recommendation.
Anyone wants to comment? Yeah.
Yes, another particular case is when you have, for example, a misfunding from private and public funding. So in some cases, you are not, you are forbidden to publish this or to make public the data and even the code. So it's maybe this did not happen. in astronomy, but maybe in biology and another biomedical science. So it's something that is difficult probably to deal in some aspects.
So I would say that one important thing that is already here is the collaborator's opinion. That's important. I mean, we have been talking about this, like the culture about sharing or not sharing. So in the end, if there are people that don't agree, that's a problem. I mean, you can always try to convince them, or the other way around, but that's important. So the research culture, that's very, very important. There was another question there, I guess.
Yeah, I just wanted to say my response was about proprietary code. That actually means in my field of research, which is more about electromagnetics, that we can build the code for solving, let's say, Maxwell's equations from zero. So we use some software. Usually these software are also involved in research activities such as the SKA, and they actually boast about it, I mean, for advertising purposes. But in the end, you need licenses, you need a lot of, so I think there should be some kind of push in that direction, that big companies are involved and gain also, let's say, advantages by supporting such research. Should at least adopt practices which are more, if not open source, rather kind of more inclusive, at least in the circle of researchers that do the same thing.
Well, this reminds me of the question in the first session, I think, was for Lourdes, that someone was asking how we can get private companies with no public funding, private companies adopt these open practices, no? Because what they are gaining, no? We need to think what they are gaining, and sometimes the model is changing. We were commenting that sometimes some software companies, they sell the license, but they open the source in order to have an advantages now for the maintaining of the software, no? Because if you open the software to the community, you can get this software updated by the community, and this is a business model in some way, no? So we are talking about open science in the academic research, in the academic world, with companies that are funded by public money, but in the pure private companies, this could be difficult, but for sure, they will find a way why open science is also economical beneficial for them.
I mean, I see a lot of times companies in their application portfolio having applications that have to do with science, and this is usually cutting edge technology, so they gain a lot of customers because of that. But in the end, when they apply the same rules for the people who are doing science to the with respect to people who are doing something else, which is for profit, there is a kind of I don't know, ethical, let's say,
For
concern.
you mean?
I mean, there should be different rules. We should push for different rules when the results of the use of such software is purely for science.
I think it is very interesting what you said. I was going to comment on something else, but it's very interesting because companies always find a way to make money. So it's a matter of changing the business model. So in that sense, I'm confident that with time, smart companies will find a way to make money in open or close or whatever science we want to do. What I wanted to say concerning Stephen's comment is that I agree we need to ban this idea that I will give you the data under request, because the first thing I wonder is how can a serious referee, and we have been doing this for centuries, maybe for decades, say that a paper is from her or his point of view correct if you didn't even touch the data. this is not serious. You are making an evaluation of the story told in the paper. So we need to stop thinking if we like the story in the paper. And that's for me the important point. Papers are stories in less and less. This is happening, but till now, for the last 400 years, papers are stories, and that's it. You tell a nice story, you make it to paper published.
That's a very good point. So let's move on. I think there are more. Okay, so let's move on to a different topic. So considering all that we have been discussing these days, would you like to change the way you present your CV in a way to explain your open science practice, if any? Just please, Rachel.
I can explain a little bit about how I do this. We had some really great examples from Alexandra's talk yesterday about how to incorporate this. Something that I do is that, I've got a bit of a profile paragraph at the top where, I kind of emphasize my engagement in open science and communities that I'm a part of. Sorry, I think it was too close to the microphone. But then also as I go throughout my CV and I, have bullet points on the work that I've done, it's easy to add, a link to repository for, the software that you've developed, or, in your publication section, you can also have, a data publication section where you're also citing your data that you've shared and linking to the DOIs there. So those are kind of really easy ways to get started with.
Okay, so I see a lot of people that still don't know very well how to do it, and I would say that this is not strange. I mean, it's not easy. It's not easy because, for example, when many CVs have templates, many times there is no place for this. So sometimes you have to try to put some pieces of information here and there to try to describe this. So it's not really easy, but we also have to remind that with the research career assessment agreement, things are going to change. So in some places, they are already saying that, okay, we are taking into account for the evaluation, even if there is no section in the CV template, that you are following open science practices. So we need to really find the place. I don't know if any of the people who said that they still don't know very well how to do it, they want to maybe comment. Maybe people in Zoom or here in person. Or maybe Rachel's comment was helpful enough to clarify.
Thank you. Yeah, the problem of templates is really important, like especially in Spain, where we have this normalized CV that we can only use that to submit. So the basic thing is to be creative, put this word in multiple places, like when you're mentioning the name of the paper, put an open like data or something in parentheses in front of it. Yeah, put it inside somewhere, the best place you can find, or many places. Just be creative.
Yes, to add, but luckily in the last updates of the CVs, at least in Spain, we have the narrative section. Yes, that's what Alexander suggested, that you have a narrative section where you can't stress there what you are doing on open science.
So I was wondering, maybe can you raise your hand, because I don't have this question in the in the presentation. Can you raise your hand, also those in Zoom, who already is describing in their CV that they are either sharing code, data, or maybe a different aspect of the open science? Is there? I mean, how many people? Just raise your hand. People in Zoom too, please. Just to have a, so for those in Zoom, there is a camera that is showing the panel and the audience. So if you want to, well, the panel, if you want to take a look at them, you can also do it. Okay, so let's move on. So this is a longer question to answer. So do you agree with these different reasons not to share code in that is related to a paper? So we always see this I mean, we have the feeling we have maybe not a software developer, so my code is kind of crap. So I'm not professional. Should I really share it? I'm embarrassed. So maybe that's one reason. Or maybe that my code is not complete. It's not ready to be released. So maybe I prefer to skip it. Yes.
So by agree, do you mean acknowledge? Like, do I acknowledge that people have this worry, or do I?
That you acknowledge that this is that
Yeah.
you agree with this reason. Like, for example, I don't like to share code, or I wouldn't do it because my code is very bad.
Yeah.
If this piece of code in particular is bad, the other maybe is marvelous. But if this particular piece of code is very bad, I don't want to share it. Like, I wouldn't do it because of that reason. Yeah.
Yeah. Okay. Thank you.
So something also very typical, the people that was involved in the development or the goal, they left, maybe they moved to another position, or competitors. I mean, for many people, in the end, I mean, you need funding, you are competing for funding, so there is the competition factor there. And maybe if you share the code, a lot of people is going to be asking around why this is not working to me. So. So in the meantime, people are still answering. So I don't know. Maybe Ruben, maybe
I would like
you
to
want to
add to
comment.
this question related to the data. So sometimes in astronomy, we see that a project is running for 5 years. And then when the data release is ready, they kept the data for 1-2 years for the team to try to have time to develop the science. Why is that the reason for people not in astronomy? Because usually that's not credit. All the time you spend in a project developing code, checking the data, etc., that's not in your CV and you cannot be credited for. So that's why they give the 2 years time to develop your science, because then if you release that, you are in an unfair position with other people who hasn't spent the time. So what do you think of, obviously, if the evaluation rules change, this that doesn't make any sense. But what do you think with this rule or culture that we have been having for the last 2 decades in astronomy in particular? I don't know if other people from other fields have this issue as well, and if they want to share their experience with this.
Anyone want to comment on that?
I can comment something in the meantime. So sometimes when we discuss in the group about this issue, we always say this is like the fish problem, because you don't did this because you don't get acknowledgement, and you but we are seeing that this round is breaking because people is understanding that sharing their data or their code is beneficial for them, because they are getting more. People understand that your work is more reusable, and you get more references, citations, and this is something that is not a comment. There is a publication around, I think, I don't know if Lourdes or in your talk, if you share your data, you can get more citation at some point. So I realized that we started to work on these kind of things a lot of years ago with Lourdes, and I realized that this fish problem is breaking for the bottom. People is changing the rule before the evaluators or the research fundings change their rules, because they are starting to share their data before to get acknowledgement or recognition for that. So, well, there's a trend there.
So, Rachel, would you like to comment on I mean, there are 2 main reasons and arguments that people agree. So maybe.
Yeah. So I can totally empathize and relate to the first one. I'm not skilled in software development. My codes and scripts are ugly, to use the terminology up there. Something that has been really emphasized in the Turing Way project is, and something, is that, you know, we need to make it okay to be human. You know, mistakes happen, as we heard from Javier's talk. You know, we kind of have this burden of having to have all of these different skills, but there's no way that we can be perfect or, you know, fluent in everything. So I think we need to really cultivate that culture of sharing so that we're not embarrassed to share, you know, our ugly scripts. And that, you know, it's really more of an opportunity to then get collaboration with people who do have those skills, who can maybe help us clean up our scripts in a better way and make them more sustainable and maintainable and efficient. What was the other one? I didn't work out the details.
It's not finished, not complete.
It's not completed. Yes, so culture for collaboration. So if you don't know how to finish it, or you know, how to work out all of those details, you know, being able to go out into the community to find somebody who can help you. If you're developing on, you know, for example, GitHub, one of the many other repositories that we've heard, you know, it's out there for others to help you with, and collaboration. And then, you know, we need collaboration in order to actually do research, but we only get rewarded for our individual, you know, publication record. So I think it's really important that we really need to support each other and change this culture of reward to be like, well, you know, a paper could come out of, you know, this particular software that's being written. If I contribute to it, then, you know, maybe I can become a co-author on this paper, you know, if we work collaboratively together. And so for the existing incentive structure, I also think it's hugely satisfying and hugely rewarding to build those collaborations with your peers, especially if you can all bring different skill sets to a problem. Don't know if I actually answered your question or if I
mean, it's a fair comment, I would say. Yeah, Tiffany?
Yes, your comments actually remind me of a particular situation in astronomy. Is the AstroPi package has been developed, or which has been developed by predominantly, I think, early career researchers. And so this is foundational to the use of Python in astronomy. It's so ubiquitous. It is so useful. And yet it has been just volunteer effort by early career researchers. And I think it's great that early career researchers are at the vanguard here. Also, the community needs to be looking after the interests of those early career researchers. And I don't want to see, you know, someone. I don't want to see the younger community getting exploited by astronomy. This is a particular UK perspective. We had some recommendations to our grant awarding body, STFC, and we said that they should be looking at the career roles and contributions, particularly people in technical roles, because it's an underserved, under-noticed part of the career structure in astronomy. It's not specific to the UK. I would say this is quite a general problem, but I think it's something that astronomy in particular. I mean, we've been in the vanguard of open science, open data, archive, virtual observatory for years and years and years. We should be at the vanguard here in the career structure as well. But on the other hand, advisory panels never get listened to. So it's like screaming into the void sometimes.
Thank you. Yeah, about AstroPi is a really nice example. It started with a few postdocs, and then they went on to some other jobs, and they continued, and then they actually made a company. So now they're actually it's actually led. So they're leading a company, and they're mostly providing services to solar physics. So solar observatories are paying them and supporting them, but not as postdocs anymore. They're now actually a company that's making money on the free software Foundation.
Oh,
They're
that is
based in-
awesome.
They're based
didn't
in
know that.
Britain. They're based in Britain. in
Yeah.
Yeah.
That's glorious. But they've done it through free enterprise. They've done it.
Exactly. So
Yeah,
I
right,
really
okay.
like their approach. They actually made a sustainable software and they're providing services to astronomical facilities.
That's fabulous. It should be academia doing this for them.
Exactly. I mean, it's really
but
good.
yeah, wow, that's fantastic.
Okay, so let's move on. A little bit. I hope you can read it. Not sure. I mean, in which two areas do you think that, so you can mark two, in which two areas do you think that open science practices will trigger more changes? And let me read it because at least here we cannot see this very well. Digital infrastructures, like for example, for services or sharing data or software or these kind of things. Research career evaluation, equity and fairness, diversity and inclusiveness, the peer review process, or transparency and reproducibility. Just quite variety. So in the meantime, I don't know, maybe I can see that Ruben is still thinking, so maybe Rachel.
I feel like I've been talking a lot.
Me too, right?
Only two. Oh no, Susanna already answered. So Susanna.
Well, I don't think if I agree the answer here. In my opinion, but now it's changing. In my opinion, the biggest changes will come from the evaluation part, no? Because now in the last year we have seen how the digital infrastructure we have changed in order to provide support to researchers to open their work. Now it's time to support evaluators to open their evaluation and to support, Lourdes mentioned before, you cannot do your evaluation reading the paper. You need to see the data. What happens when the data is 1 terabyte, 2 terabytes, 100 terabytes? You need to execute a software and you need to provide a good evaluation of the software. You need time, you need tools. You need tools to facilitate this evaluation. So I think that now that with this COARA, this ENCA, all these big agreements with the biggest funders and the people with the money, that they ask us to do very good evaluation of the scientific career. The evaluator will ask us to the engineers tools for facilitate their work. So because now the tools that now need is a PDF Acrobat reader in order to evaluate, or maybe it's too exaggerated, but in the next 10 years or something, I think that we need to do on the quality of the software, automation of how to evaluate the quality of the software. No? So I think this will be maybe this, I'm biased because I am an engineer, I'm thinking on digital infrastructure.
I mean, there is no correct answer here. So everyone has their own opinion, that's fine. So, but we can see that in general, people think that the field, the area where there will be more changes will be transparency and reproducibility. It makes sense. I mean, not the only one, but it makes sense. So, yeah.
If may I to add, it's a minor, but I think it's important also inclusivity and diversity. And I think open science will give that culture into the access to other people to access the data. For example, PDFs are not very accessible for visually impaired people. So we have to provide or to use we have been checking today that it's important to work with plain text files that are very accessible. Google Docs are totally inaccessible by VoiceOver and other things. So I think open science will also play a fundamental role in inclusivity and diversity.
Lourdes, yes.
I fully agree. And in fact, what I have marked in my answers is not where I think is going to be more obvious. Obviously, it's going to have an impact in transparency and reproducibility by definition. But I put equity and fairness because I really, even if this might kind of be unseen or not so obvious, we really need that so much. We cannot keep the model of the institutes, the countries having the higher incomes, the higher capacities to buy journals, to pay for journals, drive the science we do. That's bad for science and that's bad for the planet. And we cannot keep people being unrecognized just because in some places we know that not necessarily third world countries, but often there are strong hierarchies. So is there one person who signs and the work of the others is not well recognized? And well, I said these things in my talk. It's about also anonymized work of women. So I think this is an area where we really need the impact of open science. And this is kind of a end result. So transparency and reproducibility is the mean to achieve these other things that are so necessary for our society and our planet.
Okay, so moving on. So do you agree or not with this? Can you trust the results that are based on maybe citizen science? Like, I mean, we were talking about this earlier in the day. And also, can you trust, for example, the results that are based on deep learning, convolutional networks, or similar artificial intelligence techniques that are black box, so you don't really know what's really happening inside there. In experience, just can say that they are performing well, but you don't really know. So can you trust? I can see that in general people trust. So I don't know, Stephanie, if you want to comment on this.
Well, firstly, I think someone should pose this question to Chat GPT and see what it says. To me, this question is I want to abstain from this because it depends what you do with it. That's kind of how I feel about it. So it's a bit like saying, do you trust radio astronomy data from heterodyne receivers or bolometers? Or do you trust optical data from CCDs or CMOS detectors? And yeah, it depends on the data. It depends how you've analyzed it. It depends how you've aggregated the citizen science data. It depends how well trained the deep learning is, how big your training set is, how big your test set is, whether you had a validation set separately. There's a lot of stuff you've got to assume on this. So personally, I'm minded to abstain. You could, just say in general, on average of the ones you've seen on archive. So yeah, so that's my view. I would abstain.
It's interesting to see that the people in general trust more in the people than in the algorithm. So that's something very interesting. So I don't know, maybe would you like to comment on this?
Well, we are biointelligent, not artificial, but biointelligent, right? And we sometimes don't understand how our thought or brain works. For example, for visually, when we inspect visually images, morphology and the like, we really are not clear about how we interpret that. And I think with in artificial intelligence, that they are interpreting well the data, we can try to understand ourselves as well, comparing with other intelligence. So I think, it's a combination of both forces, and I think it's positive in that way.
So my comment about this question is that it's depending on what kind of artificial intelligence are you using. See, the algorithm already made by me. I trust on my science, my algorithm. But for example, ChatGPT lies every time. Every time. For example, if you ask them for a reference about some particular scientific topic, you cannot trust the reference because the reference is a mix between authors already engaged in the topic and the title of books connected, but not belonging to the same author. So it's at least the free one. All right. I don't know if you pay for something, the number of likes is low.
Well, in theory, ChatGPT was designed to avoid plagiarism. So that's one of the reasons why it's harder to get the references. I'm not the only one, probably, but yeah. Oh, yes, please. You were
Yeah, I just wanted to say that I think this is quite a recent concern because initially the models used for, let's say, AI or machine learning were lighter. So there could be some understanding, but now it's more like an emergent behavior out of millions, billions of synapses, etc. So even people who are researching this topic are trying to understand, not because they don't have access to the code, but because it's such a big problem. So I think we should follow more like the experts on their efforts in understanding it rather than accepting or dismissing outright what the AI gives us.
Yeah, well, I think you just need to know the strength and the weakness of whatever method you do, machine learning or citizen science or whatever. Well, this is just things that I see, for example, on social media, people asking ChatGPT, what is 1 + 1, and ChatGPT get it wrong, and then they say, oh, this is shit. ChatGPT is not trained for that, so we just need to know that. Well, I think the speaker in the morning already said like there are cases where machine learning. There are cases where machine learning performs better than the citizen science, and there are cases where citizen science performs better than the AI. So you just need to know the strengths and weaknesses of all of these tools that you have.
Yeah, very good point. I mean, we could spend the whole day talking about artificial intelligence and the risk, but maybe not for today. So let's move on. Sorry about this. Yeah. So which tools are the 3 most useful? Oh, this is probably yes, but it doesn't matter. Which tools do you think that are the most useful from those that we have been discussing these 3 days? So let me read it. Software heritage, the archive, the virtual observatory services, the Jupyter Lab, containers, source packages, managers like Conda, Manage and SnakeMake, other workflow managers, licenses, Binder, and platforms like the Escape or Citizen Science. Again, there is no correct answer here, but well. I think someone listened to that. So maybe, I don't know, any of you would like to comment, maybe share your opinion.
I mean, yeah, I would have said licenses is number 1, because nobody else can reuse anything you do unless you put a license on it. I think workflow managers are increasingly important as we automate things. So that's one that I selected. I noticed you didn't put the Turing Way up here.
Sorry about that. Sorry. I know it's not a complete list, but yeah. Ruben, for example, if there are anything of those things that you were not using, the ones that you were not using, I mean, good.
Well, I'm now interested in citizen science, so that's why I put it there. And I wasn't using it before, so I'm really keen to develop that, and I'm looking forward to it.
Then I'm going to reply from this lane.
Oh, very good. But other from the, for example, the workforce, I agree. I mean, they are super interesting. I think something to use I had kind of rudimentary workflows for myself, but now I see there are professional or very advanced tools, and for sure I will adopt it.
Okay, that's great. So forget about this again. This is for the kind of slide. So can we skip one? No. Okay, so our services and infrastructures in place to support open science across the entire research cycle. What do you think? Maybe Susana or Ruben, would you like to comment on that?
I will say we are close, but there is maybe not so close, but we need to do things, but we are much closer than maybe 5 years ago or 10 years ago. Yeah.
So, for example, some of the people that are already working on their thesis, do you feel that you have what is needed to make your thesis work? Sefide probably could. I know she would say yes, but
Well, I would say no, because like Amidu thought, like in the astronomy data, in radio astronomy, because for example, there are so many steps that involve human intervention. That is not like that is impossible to automate. So I think in that regard, you release a paper and maybe you put some codes, but these codes are like after so many steps. And even if you release the code to do plotting or whatever, there's so many steps before that is not included in those reproducible papers. So I think even if people release data code or whatever, there are so many hidden steps that is just impossible to reproduce. And I think we are still far.
yeah, thank you. That's a very fair point. And there are some tools, for example, that they create some kind of log. This happens, for example, this can be done, I think, in Aladdin, or I think it was Aladdin. They can export a log in Python, so you can kind of recreate what you did interactively. This is just an example. It's not the usual case, but that's something to consider when we are developing tools. Can you kind of track the things that are done by hand? So, and sometimes the answer is yes, sometimes maybe the answer is no, but that's something to consider for, I mean, the developer should maybe consider.
For the developer, as Javier mentioned before, he's not here, but Javier in his talk before, just 1 hour ago, he gave a very good advice. If you are visualizing things in an interactive way, and then finally you get the data that you want, maybe you can log this manually, not the tool, but you manually you can put a code line in order to capture this step, no? So, but it's true that it's difficult to capture every single step. Yeah,
That's true.
Yeah, and there are some ways that you cannot work around about doing manually. For example, if you don't find an algorithm that works for masking stars or whatever, or other type of things. And in our case, I did it for Khalifa. My student is doing it for another thing, that algorithms are not masking well. So you have to do it by hand, or at least have a human inspecting that. And that's hard to record. At least you can keep all the files uploaded to Zenodo, and the maskings are there. But the process of how you mask that and what are the criteria, you can record it somewhere. In the paper, normally you have narrative, and you put a very short sentence or paragraph on that. And the other thing is data acquisition. I mean, now all the observatories are quite automatic, and they have a pipeline where you put the data, and the telescopes start observing. but up to the recent years, it was like manually. You have a log, but it was difficult to reproduce the acquisition. It was nice with that kind of seeing, when did you point it, what was the elevation, and to gather all the information exactly of what the telescope on the conditions of the night, that's difficult to tackle, and especially for surveys lasting for 4 years. So that acquisition is also very important to try to get the information of how it was taken, and that applies for always for bio, or I mean, you have to take data and cannot be automated. You have to work with the pipette and all the small things, and that's difficult to log. It would be nice to have a standardization of how we do things, how we put things that we have to do for sure manually, and how to keep record of all of that data and process.
Thank you. So the masking case was one example that I've also had to confront it several times. The way I done it was that I just kept, for example, if I wanted to mask a circle, and I chose that circle manually for any reason, I just kept the coordinates, the RA deca of the center and the radius in a configuration file. And then I would, because the run parameters you need are just the RA deca and then the size. And then in my script, in my reproducible pipeline, I would read that configuration file and manually mask it. Well, not manually inside the computer, inside the pipeline, I would read those coordinates and mask those pixels.
I'm glad we get to the same.
Yeah, because sharing the data would be huge because data are big.
Right.
And like uploading the masks would be a big burden on on your pipeline for yourself in the future, for example. Yeah, and about the data observations and reproducing observations, well, we should. It's good to separate. That's replicability. There are we can have a whole meeting on like how to do replicable science. But I think over here, open science also involves replicability. I don't know how. It's a big point. It's an important.
It's part of the process of the science. I mean, maybe it's another subject, but it's also important to keep that. This is lagging behind.
I agree.
Not in astronomy, at least, but other fields still need that.
Yeah, like in medicine, their main problem is replicability, not reproducibility. Thank you.
Yeah, for sure, that's part of the process. It's very well connected with open science. There are many errors. That are to be considered. Okay, so let's move on. What are the most important benefits of sharing data and software in your view? Like, for example, paper more likely to be cited, data and software reuse, papers more likely to be accepted for publication, or transparency, reproducibility of research, encourage others researchers. So you are doing, and you want others to do it by showing by example. More possibilities for collaboration, compliance with funding body mandates, and for others to check my work and seek for improvements. I mean, this list is for sure not complete. So if anyone wants to comment about others, I don't know. Just give you a few seconds. Can you only? Okay, so the most, the most important. Yeah, sorry about that. Anyway, we probably all agree that all these are important things, but almost all. But
I can comment something. I think something important when you open your research is that it can be understood. And now that we are working in a very large collaborations, in a very interdisciplinary groups, engineers, people from different fields, it is very important that your work is understood by your colleagues or by other people. And when you open and provide good documentation, provide the right things, it's not only to put there and you can download the data, but you provide all the metadata in order to understand what is happening there. I think the benefits of this is more some of these things. No, is transparency, is reproducibility. No, because when someone can understand something, this person will be able to reproduce your work, because it's even if without the data and the software, because he can repeat this work in a different field. No, so in my as an engineer working on astrophysics groups, for me it's very important to have different kind of documentation, data, software, in order to understand, because I am not an expert on the field, but I realize that it's not only because I am out of the astrophysics world, even inside of the astrophysics, people from solar, they need to talk each other. And the right way to do it is because if they understood what they are doing, no?
Okay. I didn't have the experience yet, but I think the benefits that I can think of is also the amount of reaction that you get from the people or the feedback, because when you release your code and people will, well, there are probably things that you didn't think of that people might say, oh, look at this, try to give feedback and reaction. Like, well, I remember my supervisor always say, like, people don't act, they react. So.
That's a really good point. Like, I don't know if you've experienced, like, somebody will, you might put your paper on archive as a preprint, before it's officially published, or even after it's officially published. And you'll get, emails immediately saying, oh, I'm working on this, why didn't you cite this? Or, you could have done it this way. And that's kind of why, a lot of that is unsolicited feedback, but in some cases that could be really, really useful, because, diversity of backgrounds and skills in a project in order to cover all those perspectives. And so there's a lot of encouragement around, sharing a preprint of your work before you actually submit it for publication, so you can get that feedback from the community. Now, of course, a barrier to that is this fear that you'll get scooped, somebody else will actually, submit that to a journal before you can. But a benefit of having it on archive is that you have that official stamp. You have the date, you have, that link on archive showing that you are working on this and you were the first person to, share it widely. And the real reaction should be, somebody saying, oh, we're also working on this. Maybe we should collaborate and finish the paper off, together. But that's really not the current incentive structure. And so that's something that we still need to kind of shift a bit in order to get that more collaborative approach to these things.
Yeah, thanks. Just for a comment on this, because, we always say, like, for others to use, right? Like in my case from 2015, when I put my first thesis paper, there was, what they say, prehistoric manage, it wasn't managed, but it was becoming managed later. I thought the day after I publish, people are going to pick up the code and not let me use it for my thesis. They're going to take it sooner. But then in practice, I noticed that it took me almost 3 years of conferences to even make people interested in listening to what I have to say. So it takes a long time, because what's happening right now in many fields, from optical to radio to everything, we're flooded in data. We're literally flooded. People, unfortunately, this is just something to take in mind. Yes, it's great that that people in potential can come and reproduce your results, but in practice, the person who's most going to be reproducing your results is yourself. In the next papers. So one tip of motivation, for especially the people who want to publish their first reproducible paper, is that probably it's going to take a long time for the community to be able to, or someone to spend enough time to read your code to be able to understand it. So don't get disappointed if you see that, like, not too many people are going to implement your reproducible paper. But write it for yourself, your future self, as Javier was saying. Your future self is the most important person that's going to be using your work, and it's really valuable for that person, yourself, to do a nice work in reproducibility.
There's that famous quote in software carpentry where, you know, your most frequent collaborator is yourself, you know, 6 months from now, but, you know, your past self doesn't answer emails.
Okay, so I think it was Eva, the person who was talking about batch and reproducibility batch. Something similar to, for example, what was done in the SK data challenge. Did that this kind of batches motivate you to share code, data, or other artifacts? This could be, for example, this could be included in the journal. It could be in your code repository. This can be implemented in many ways, but is this a motivation for you?
Well, I gave some feedback from this question, a software developer who told me it's a lot of work. It's a very huge work because he was developing a very huge program. So if you are only to an opening and doing the things correctly and all these things, if you are going to do to get only a batch, maybe it's not enough. I understood, he doesn't tell me that, but I understood that if this batch is together with other things, so people evaluating things, pay attention to this kind of batch, it could be better, no? So I think that, yeah, you can get a batch for small things, no? You put a license in your repository and you get a batch with that. Your repository has a license and is one step further to open science, no? But this is easy because it's just a filing. But when you need to documentation, CD, CI work, all these kind of things, the things are more complicated and you want other kind of rewards.
Okay, thank you, Susana. So there is a mix of answers here, but in general, people more or less could be happy having these matches, like additional motivation. That's fine. I mean, this really depends on the person. And at some point, you compare to others. That's an important thing. So it probably depends if that match is famous or not. But, so let me. Well, before coming to that, let me just ask a question to the panel before going to the last question. So, in which way could you say that we could fairly credit a work that we have reused? So, for example, that imagine that your research is using a pipeline or someone else's research, but not just like the conclusion from another paper. So something more deep, like you really are reusing someone else's work to build on top and do something. So how can you really fairly credit that?
That's a tough question.
Well, first thing is it make them knowledge, make them let them know that you are reusing their work. So maybe they can tell you how you can acknowledge their work. Maybe they want to have a citation. Maybe they want that in the conferences maybe they want to collaborate with you. Maybe they want to be part of your work or to make a project together. I don't know, but maybe the first thing to do is let them know that you are going to reuse their work in some way.
Well, Mohammed's approach is really thorough in that, as you mentioned. I mean, with your managed package, you can acknowledge all the code that you are using. But also it's important when you mention parts of the codes, how do you acknowledge parts of codes in that sense?
But that's software heritage. We can get
right.
But my question is more in the sense that like this hypothetical work wouldn't be possible at all without reusing that unless you start from scratch. So imagine, like, for example, having that piece of research pipeline, whatever, is like 80% of your research. So you did just the 20% remaining, something like that, just to give an example.
I think you would need to put yourself in that place. So what would you hope that somebody would do if they were building off of your work? I think I completely agree with Susanna. I think, you know, contacting the person, letting them know, because I think that's really, really valuable, especially in kind of creating a more welcoming research culture, just, you know, letting people know that the work is really valuable to what you're trying to do and what you're trying to accomplish. Offer collaboration, offer to also like contribute back. So if you're reusing software and you're building upon it, you know, contribute back into that code base, you know, give feedback, fix bugs, add to the documentation, you know, things that really helped for you. You know, currently we're rewarded by publications, authorship, so maybe it's worth, you know, inviting them to be a co-author on a paper. They can, you know, read through your manuscript and offer feedback on what you've done and become a collaborator. The acknowledgement section, definitely, you know, most projects will have information on how they want to be acknowledged. So, you know, whether it's citing a paper, whether it's just adding a line to the acknowledgement section. But I think if you're really going to be reusing and rebuilding off of something to that degree that you've given as an example, I think reaching out to those people would make a really fruitful collaboration.
Okay, so I don't know if anyone else from the audience have an opinion on this. Yeah, Mohammed.
Thanks. So what I feel, for example, let's put it on a hardware example, like SKA. Now SKA is being built. You're putting so much energy on like the Spanish data center. You're putting energy on the British data center and all the different components. But the people that finally use it, probably you guys will be in some big managerial roles. You'll be a professor by the time SKA starts. Those people that come, you know, you've spent 10 years preparing this SKA, and then those people that come, they're just gonna, you know, in 2 years, they're gonna publish papers. And so, you know, you spent 10 years writing. But the thing is that you've written your papers on defining SKA. So, and you've built a career, you've done your, you know, you've the builders of something, they've done their job, and the fact that you can do your work with 20% of like the total in your example is a success sign for the people who built that tool. So I think it's great that you should you should publish, you should cite them, because they get cited. You should contact them and just publish more to help get the thing that they built, you know, more scientific, you know, let's say visibility, because they spent a lot of time building that tool. So publish more and continue citing. Yeah,
that's very good. Yeah.
I'd also like to come back to something that Stephen said earlier about recognizing a lot of the hidden labor, particularly in technician roles. So I'm actually currently in that position. So I used to be on the research track, and then I switched to becoming a project manager. And so now I'm in professional services. But I am, you know, a core part of the team that wrote the UK SRC proposal, but I wasn't able to be listed as, you know, an official PI or co-I. And, you know, when I submit proposals now, you know, even though they go through the peer review process, they get accepted, they get awarded, the feedback I then get at the end is, oh, you can't actually be PI on this. Who on your team is an academic that we can actually name as PI on this? And so that can have a huge impact on morale within a project. It has a huge impact on the people who are absolutely crucial to getting that work done. And being able to acknowledge and reward that labor is something that this community really needs to work on. So like you said, now UKRI have, you know, a policy in place. Whether or not that's in time for me, I don't know, but that's something I've fed back, because yeah, your software developers, your data stewards, your community managers, your project managers, your project isn't going to work without them, especially on the scale of the SKD. So, just because somebody isn't officially a researcher, that's no reason to, not give them the credit that they deserve for contributing to the project.
That's a shocker. My God. Are you able to say anything about which funding agency was involved there? You don't have to. I mean, it may be we have to put to someone under the microscope.
I just want to remind you that this is being recorded.
I can see you afterwards.
Sure.
I have pushed back on it. I'm
Good.
currently waiting to hear about the results of that pushback. But, it makes you, that should have been made transparent from the beginning before all of that work was invested. And then B, it makes you question whether or not to put that much work and effort into it in the future.
Of course. Yeah. I feeling in sympathy.
Okay, we can continue with that discussion later. But the time will 5 minutes, 6 minutes to the end. So let me just skip this one and go to this one. This more philosophical question, will everyone be following open science principle, for example, in 10 years from now? And for that, in that case, the answer is yes. What are the challenges for implementing these open science practices to make that possible? How can we address those challenges? So
This is interesting because you've only got the option to click thumbs up. You can do it at any time if you like.
It's you the one doing that. No?
Well, I'm going to repeat myself, but I think yes, we are going to follow in open science principle, but I don't know to what extent. No, if this open science is going to be applied to to the whole research cycle. There's challenges with the evaluation of the science of the work. There are challenges capturing these interactive steps and hidden step in the science. So I am completely sure that we are going to do the basic. The basic means open your data, open your software, provide good metadata so your work can be found in an easy way, make things more interoperable, follow standards, all these kind of things. But probably there will be some specific things that we cannot do it, no, because I don't know. Right now, I'm thinking more on this evaluation of the research, but you can think also on, as in our case, no, the SKA, the big data, how we can manage all the data. Maybe.
In fact, Susana, think that in 10 years from now, SKA Observatory will be built. Okay. So it should be being observing. The regional center should be working and providing all the services that they are supposed to provide. So you can also think about what will be SKA be doing regarding open science in 10 years from now, when everything is built.
Yeah, we can think on how will be, if you are asking me, how will be this SRC network and the challenges for the SRC network to support open science. We have been working a lot in the SRC network effort to achieve this. And yes, in our ideal world, so if this was an ideal world, you have a science platform in which you can, or many specific science platform specific for different fields. But from this science platform, you will get all the data and you will find services for your research. You will authenticate with your institutional credential, and you will see the data that you have permission to access to. You will have a visualization service, very nice, in which you can pick 1 terabyte data cube and put there. And don't be aware that this is running in a Chinese server with a GPU, 100% of uses of the memory. You are not going to be aware of that while you are doing these kind of things with a 1 terabyte data set. But this is difficult because all these, there are services, tools for everything, but we need to make them interoperable.
To work together, yeah.
First part, and we need to make them running on a distributed computing center that are totally different. They are heterogeneous. They are not providing the same resources. This is the challenge. So maybe this ideal world is not so ideal, and maybe you are a bit aware where is the data, because you need to use a specific software, and you need to think, okay, the big data is there. Maybe I need to go to this. So the technical challenges for open science comes also with the big data challenges.
Okay, thanks, Susana. So, Rachel, you have been, I would say that you are working for this to happen. So what's your view on this?
Yeah, so yeah, I'd be curious to hear Lourdes' answer to this as well, because I feel like it's been quite slow moving for a long time, but now that we have the mandates in and policies in place to really accelerate this, I do think we'll be seeing a lot more of this in the years to come. I think with the SRC network, we're working really hard from, our side in the development of it to make it as easy for users as possible to this open science and reproducible research. But it comes back to what you said about that shift in culture. We also need to provide the training. So the summer school, we really need to, start building now the culture to, not only be able to access your data from the SKA regional centers, but also to, have that motivation and incentive to also redeposit your data back in, that once you've got your, your science result and make that available for reuse. Something that I find really encouraging, especially, is from early career researchers who are more willing and able to adapt to new ways of working. So a lot of the barriers that I've encountered over the years while advocating for new ways of working is just that, people who have been in the field for a long time are really reluctant to change their workflows. But, if you're just coming up and you start implementing, oh, maybe I'll try, using version control as part of my work, as somebody who does not identify as a programmer or a software developer, the fact that I love using GitHub so much, I think, is a real testament to how these tools can help you in your work. It's not just, a software repository. It's also really good for project management and just open collaboration in general. So, finding tools that really work for you is a really great way to get started. But, we're scientists, we're always looking for the next thing. We're always working to innovate. So we shouldn't really be that reluctant to try out new tools, learn new languages, use new instruments. So I think just that willingness to learn and adapt as this landscape changes is really crucial. And I think that enthusiasm for that will be coming from early career researchers, especially.
Thank you, Rachel. So, Ruben, could you like to?
Well, yesterday I was talking quite a lot with Alexander, and he was contributing quite a lot to the Quora and other open science things 5 years ago. And he was quite surprised how advanced was 5 years later, all these subjects. So using that prior, I would say in 10 years time, this is going to be really quite open and distributed and culturally distributed among all of us. But this is, here we're talking about very heavily dependent on computer, but there are other disciplines, humanities and other things that also need this kind of culture that doesn't depend on all these, or not heavily dependent on all these tools. So I think it would be also nice to distribute or to share this culture with other disciplines and to open research, as Alexander said, to all kind of academic disciplines.
Okay, thank you. So let's just take one comment from the audience because it's already
Yeah,
okay.
I just want to ask
Let us try to.
a question. So the SKA policy, well, let's say in 10 years, do you think that they will like force everyone to say, okay, if you use the SKA data, you have to publish in open science, or will it stay like this? Like if you wanna do it, then do it. If you don't, then don't. Or what's the perspective of the SKA?
That is not a yes/no answer, but for example, the key science projects that will be like the large, like the legacy projects of the SKA, for example, the results from those projects should come back to the archive, and this is what we call the advanced data products. So in a way, the archive is being designed, is going to be designed to be compatible with FAIR principles, and in a way with open science. I mean, you know how things work in astronomy, but we want, I mean, SK community wants that the data coming from the research come back to the archive. This is an important pitch, but it's not only the data. So one of the requirements that is being defined is that the advanced data product should be reproducible.
I was mainly asking about the publication itself,
The papers.
The papers. Like, well, when you publish, but will SKA enforce you to publish in open science way, like what Mike did, for example, in his paper? Or
well, I cannot answer about publications regarding SKO policies, but I couldn't imagine that SKO is going to define any policy to have a mandate on the papers.
I think that comes down to your institution or your country where you're based, because the SKAO is an intergovernmental organization and they wouldn't really have a mandate on the papers that you publish, but your institution does, or the EU Commission does, and those are the kinds of things that you would have to comply with at that point.
For sure, there will be some alignment, probably because the trend is that policies are targeting that things become open, not only the data, but also the method. So for sure, there will be some alignment, but not probably on the SKO side. I don't know. So Lourdes, I think she wants to.
Yes. Well, I want to say several things. One is it's exactly 10 years ago that I gave my first talk on questioning the system, the need for open science, the need for revising the way to evaluate careers. In all these years, if someone would tell me that today we would be organizing an open science school at the Institute together with the SKA, that we are building and have a functional prototype of regional center, really engage with open science, I wouldn't believe it. So I must say I take the license to say, because I'm the most senior in this area, I think probably here, I take the license to say that I'm really happy today about what has been happening. I didn't even have to do anything. This happened with all these organizers, so good people. I'm going to ask later for an applause for them. So at the beginning, it was fighting all the time against the ego of people saying, I'm doing the things right. What are you saying? It was personal for some people. The agencies didn't understand the idea of not using standard metrics for CVs. And the best way to see that is if I go myself to the first version of my talk and the version I gave on Monday, how many things I had to remove because it was not anymore needed, because people is really changing the way they think. And especially all these policies didn't exist at all when I started giving the talk. And it was so good to find other people having the same feelings and ideas. And I think it has been a very nice endeavor with finding Rachel and Eva and many people in the way, because this is a crusade. And this is a crusade for something we do, and it's science. And we want it to be science. So convincing people that we can do it better is not so easy, because sometimes you don't realize that you don't have to criticize, you have to give the ideas and the tools, because at the end we all do the best we can do, right? So I think this is a great day, a great school. It is great that Julian, I want to an applause for Julian, who has been doing all the work, so please. The work for the school, but there is a lot of people here doing the work in different areas here at the institute and beyond, and I think this is very important. I didn't dream about that, so I think that in 10 years is going to change enormously, because people will really not only believe we have to do it, understand why, but also have more tools. And also there is a new generation, and I really trust the new generation and the compromise. So that's my conclusion.
Thank you, Lourdes. So, Mohammed, I think you wanted to add something. We are late, but I mean.
So I just wanted to about the challenges. The point, the first question, where like I have ugly code and I'm scared of sharing. I think that's one of the biggest challenges. So the teaching and training people, I think, is the most important. Many people love to distribute. They're very happy to distribute their code. It's just that they feel unsafe. I was also very unsafe about sharing, and I took it to the extreme. I went to GNU and then I sent my code. They refereed my code. After I got their green light, then I felt comfortable to put my code. I mean, I was really, and many people are like that. They're scared that like their code is ugly, and so it's the training and asking to bring down the standards is probably not going to convince many people, because they want to they have a self-image. It's not about others, it's not about like you accepting a low quality work from me. It's about what I want to, how I want to show myself. And so yeah, I think training is and that's why the Turing way is really good. And similar efforts to be able to train people to have a confidence that their work is not the technicalities of their work is not ugly. Thank you very much.
Okay. So thank you. Just to close, if you want to share how do you feel after this school in 1-2 words, that's okay. But in the meantime, just I would like to also thank that things are going have been running pretty smooth during these 3 days, and this is thanks to the log, thanks to Laura, to Fernando, to Irene, Marcos, Manuel. Of course, thanks again to the SOC, to the IAA and the SK Observatory for making this possible. Thanks to the panel for showing your availability for being here, and thank you to all of you for staying, even if we are running a little bit late. So I think we can close. I hope you have you take some things from this school to home. Thank you. Just one last thing that from the log side. When you before leaving, just leave the band, if you don't mind, in that table. There is in that chair and close to the door, just because this is the kind of thing that we reuse for sustainability purposes. So if you don't mind, that would be great. Thank you.